What are some of the environmental considerations as well, in terms of the operating environment? Are there opportunities there as well?
Typically, if you have motors that are not as reliable, it's a very good time to calculate in what feature sets are best for that operation.
For example?
So if you had a general purpose duty motor, cast iron or rolled steel, you notice field failure or bearing failure on a continual basis, you may need to go to an upgraded severe duty.
Okay.
Or higher.
Yeah, reliability, I think, can be evaluated at the exact same time. They're hand in hand. We're looking at it for the connections and the fit. We're looking at this drivetrain for efficiency, and it's a good point. As long as we're here, we're doing a full assessment. Let's just make sure we have the right specification for the product, for its feature set, whether it's a washdown application, a high temperature application, or other environmental considerations. Do it at the exact same time.
And John, I know that Mike mentioned the envelope as well for the motor conversion. Can you talk a little bit about what maybe some of the implications or considerations are?
Sure. We've really got two different motor constructions. We have one motor construction, which is a finned cast iron frame. The Super E parts fit within that same frame, and physically the motor will be a drop-in replacement. Where we have a little bit of a change is on our steel band round body motors. Usually on TEFCs are up through about 10 horsepower, but on open motors we go up through 100 horsepower or more. When we add the additional material needed to raise the motor efficiency, the length of active material becomes longer within the inside of the frame. And on a steel banded frame, you add length to the frame as needed to support that material. So the actual length of the motor may get a bit longer, whether it's an inch or 2 inches longer. Most applications it isn't a problem, but there will be some applications that are space restricted on a drop-in on an old piece of machinery where the new motor may not fit and they may need to repair the old motor.
Make some adjustments.
Probably, for our customers to think about it, if they know they have structural spaces where there's a constraint, the motor, gearbox assembly, if they know it's up against the side of the machine frame or another piece of equipment, that would be a flag to give careful attention there.
Okay, good.
And then you're also able to easily convert it in many instances. If it's on a V-belt drive, typically those will be ganged up in a number of V sections. You can go to a synchronous belt which carries much more power and a much smaller envelope is a way to deal with this. And in most cases, there should be a pretty quick resolution.
So let's talk a little bit then about tracking the results. If I'm an ambitious manufacturer and I'm going to be very aggressive in terms of upgrading my systems and re-engineering them, since I have to make this EISA adjustment anyway, how do I know that I'm getting the value out of that I had planned on getting? Ted, can you talk towards that?
Yeah, those systems for the best-in-class manufacturers that are monitoring their production with a lot of statistical data, if they're measuring energy per unit produced, that gives them direct feedback. They make the process upgrades on the equipment side, and that data collection will support the change they've made. And it also points to this other topic we've talked quite a bit about, which is variable speed control. Is there more we can do to optimize the process? But that becomes the scorecard. It's already installed, and they'll see that trend in their cost per unit production.
And we track that internally as well for our customers, and we use a process called documented savings.
Yeah, as applications are upgraded before and after, that's our scorecard to capture and roll up the savings.
Good, good. Mike, I know that we've all been through various plant operating environments, taking tours, working with customers, and there can be anywhere from hundreds to literally thousands of motors in some of these installations. That's got to be a daunting task for somebody who's got to go through now and examine the specifications for each of these. How do you approach that? What's the best way to kind of get the ball rolling, capture that low-hanging fruit and get started?
Really, it's going after that low-hanging fruit. I mean, just a quick tour around a plant, you look at V-belt drive applications. Conversions, you look for damper control on HVAC, blowers, valves that appear to be half open or half closed. Those are really key points, and those are where your significant savings are. That's the real low-hanging fruit.
Okay, good. So, any other applications that you can think of? Anything else that's a good tip in terms of prioritizing where you're going to start your activities? Ted?
Well, Mike touched, fans, pumps, blowers, cooling towers, dust collectors, those are all variable torque applications. That's a great family because the savings impact rolls up quickly there. But if you want to come at it from a slightly different perspective, look at the applications that have high run hours. Your energy costs and consumption there will be high. Look at the applications that are higher horsepower, and maybe a slight twist on that. Consider how many of these pieces of equipment are in the plant. For instance, if you have two 200 horsepowers, but you have 10 50 horsepowers, well, collectively, the 50 horsepowers will have a larger impact if energy savings and cost reductions are the drivers. And then if you have multiple plants in different states and regions of the country, you may have different energy costs. So prioritize the higher cost markets first as well.
Okay, good. So I'll just throw this last question then out to all of you. Given that this legislation is pending quickly, what do you feel is the best way for a manufacturer to approach their EISA conversion strategy? What are some of the key elements that you should include as you approach this issue? John, you want to start that one off?
Well, I think you really need to start at square one, and that's take a survey of the motors that you have in your facility. There's a lot of softwares available to help you do that and keep track of them and look at what the upgrades would save you. Yeah. Software such as the Baldor Energy Saving Tool or Motor Master or a number of other softwares from many of the utilities and energy programs. You can do what-if scenarios. What if I added a drive? What's my savings going to be? What's my payback? There's room there for putting in rebates. There's room for looking at what the repair cost would do when you're replacing a motor.
Decision, sure.
It would take off from the purchase price. It shows payback. The Baldor tool goes through and it prioritizes the high savings motors first, and it gives you a good executive summary that you can take to management and show them how much you're going to save.
Good. Ted, from the inventory standpoint, I know that that's something that you deal heavily with.
That's a point where we find, unfortunately, equipment's coming in from a variety of different sources, different machine builders, possibly different even just motor suppliers. So in the storeroom, yeah, that's a reality we see quite frequently. There's a lot of duplication. I've seen as many as 37 1-horsepower motors, 37 different brands of 1-horsepower motor in the storeroom. So working with the software, using this legislation as the catalyst, reviewing the application, and tie it back to the storeroom. Let's clean it all up.
And do some standardization.
Standardize it, maybe in writing a specification. That should help you as well.
I would look at really the basics of practical perspectives of motor management. There you get standardization, repair versus replace strategy, as well as when you do repair a motor, is develop a standard that motor is rewound to the efficiency that it was originally manufactured to. So those are pretty key topics to get started.
Yeah.
And from a benchmarking standpoint, how do I know if if the targets that I've established for myself are above average, below average? Am I being aggressive enough, or am I being overly optimistic?
Well, the bulk of manufacturers tend to do an internal benchmarking, but within the industry, there are a handful of very energy-intensive industries that Energy Smart and others are sort of giving some insight to what those baselines look like. So glass, pulp and paper, cement, some other common industries will have published data that you can benchmark yourself against to see, how are we doing compared to peers in the industry. Right. But I do think, by and large, the majority of folks will do an internal benchmark that says, hey, our snapshot here in 2010 is here, and we'll set an objective by 2015. We want to take 20, 30% out.
Great. Well, thank you all for being with us today. Appreciate your time and your insights on this topic, and thank you for joining us today. We hope you found our webcast helpful in exploring this issue and identifying opportunities in your facility for operational efficiencies. If you have any follow-up questions that you'd like to address to any of our panelists, please feel free to contact them directly using the information on your screen now, or call 1-800-526-2626 to reach a command representative nearest you.